Hello everyone, my name is Li Hao. Today we're going to do Advent of Code 2020. So Advent of Code is a series of programming challenges on the Advent calendar. So on every day you have one challenge which has two parts. Solving each part of the challenge will give you one gold star. So the aim of this challenge is to get 50 gold stars throughout the calendar. So today we are going to do day 18. If this is the first time you're watching this video, that means that you have missed out a lot. We have videos from day 1 all the way to day 17, and you must go and watch them, right? So links on this corner, and let's get started for today. So let's look at the calendar, day 18. So day 18, operation order. As you look out the window and notice a heavily forested continent slowly appear over the horizon, you are interrupted by the child sitting next to you. They are curious if you could help them with their math homework. Well, unfortunately, it seems like this math follows a different rules than you remember. So the homework, which is your puzzle input, consists of a series of expressions that contains an addition, multiplication, and parenthesis. Just as like normal math, parenthesis indicates that the expression inside must be evaluated before it can be used by the surrounding expressions. While addition still finds the sum of the numbers on both sides of the operator, and multiplication still finds the product. However, the rule of operator precedence have changed. Rather than evaluating multiplication before addition, the operator have the same precedence. So they're evaluated left to right regardless of the order which they appear. So for example, the steps to evaluate the expressions 1 plus 2 times 3 plus 4 times 5 plus 6, you do the plus, the sum first, and then you do the multiplication, and then 9 plus 4, you get 13, and 13 times 5, you get 65, 65 times plus 6 equals 71. So basically, you can't use normal maths anymore, you have to calculate them, right? I guess this prevents you from using eval or something of sorts where you can get the equation and you put it in somewhere to evaluate them. We have to write some, we have to write a code to actually, that follows this kind of rules of precedence. So parentheses can override this order. So when you have parentheses, you have to evaluate what is inside the parentheses first, right? So in this case, we evaluate 2 times 3 equals 6, and then 1 plus 6, 7. 5 plus 6, we have 11, and then 4 times 11, we get 44, and then we add it up again, right? So now we are going to help with this homework, which we need to evaluate the expressions on each line, and then we need to get the sum of all the results. Right? So I believe the puzzle inputs will be having multiple lines of equations, and our task here is to evaluate each of them and sum out all the results. Right? So I'm going to download this input, and I'm going to copy them into day 18. Sorry, let me move my mic. Okay, and we're gonna create a new file. Code day 19. Sorry, should be 18, right? Because this. So we have our input over here on each line, and we're gonna evaluate them. Right, so first thing first, as usual, we are going to import a file system to read the file content. And you use the right, and then we are going to split by a new line character, and for each line equation, we are going to calculate equation, and the result And then we need to calculate the sum of all the results. So we're going to have a variable called sum, which initialized with 0 and sum plus equals result. And in the end, I'm going to console log out the sum, right? So now we are going to fill in the calculate string equation. So we are going to parse the numbers one by each character one by one, right? So we're gonna have let I equals to the index, and we are going to parse it one by one. So while I less than the length of the equation, I'm going to look at the character equation I. So the equation can be any characters, right? So it can be numbers, it can be 1 to 9, 0 to 9, could be plus, it could be multiply, it can be a space, right? And it could be brackets, opening brackets and closing brackets, right? So before we start, let's strategize on what we are going to do here. So for example, let's take a look at one of the equation over here, which is 1 plus 2 times 3 plus 4 times 5 plus 6, right? So what I'm going to do here is I'm going to have a stack that will keep track of what we have parsed so far. So what this stack will do is that I will constantly push in like numbers, operators to multiply, and then 3, and then closing brackets and so forth, right? So as you can see, we in the process we remove the space, and while we are pushing in the numbers, probably I will look at, for example, right before I'm pushing in 3, I'll see that as long as the top of the stack is plus or multiply, I will take out two items and evaluate them, right? So I will evaluate 2 times 3, and that will result in 6. Then I'll push in 6 over here, right? And when I encounter something like a closing brackets, then that's like the cue for me to pop up all of this. So I will remove all this and push back 6 in, right? And as I'm pushing 6, right before I'm pushing 6 in, I'll see that the top of it has plus again, an operator, then I'll evaluate and I'll left with 7, right? And I can keep doing this operations, and in the end, I will end up with probably I can continue to do this. So next thing I will push in will be the plus, brackets, 4. So when you're pushing 4, the top of it is a bracket, so it's not plus or multiply, we just leave it be. So we continue pushing times, brackets, 5 again. The top of it before pushing 5 is open bracket, so we skip it. 5, and then we have plus, and then we have 6. And now we evaluate this, place it with 11. And then we encounter closing brackets, which we will pop out and put in 11. And then right before that, we find that there's a multiply, so we're gonna do it as 44 now. And then we encounter the last closing bracket. This time round, we will replace all this with 44 and we'll eventually end up with 21, right? And 44 or 51, in which this is the answer. So at the very end of it, I will return the stack, the top of the stack, which is stack 0, right? So this is what we are going to do, and let's take a look at how we are going to do it. So first thing is, if you see that, so we're gonna switch through character, and in case if it's a plus or a multiply or opening brackets, as you can see here, we just push them in, right? So we're gonna stack dot push character. I'm gonna break. Next thing is we will encounter blank space, which we don't do anything, right? If we encounter something like a number, so we're gonna 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. If we encounter numbers, then we need to see whether is this the only number, and we're gonna it could be 2-digit number, right? I don't think it mentioned that whether it will be only 1 digit or 2 digits, so we're gonna probably want to handle that as well. So I'm gonna have a variable called number, which initializes with char, and then probably need a scope. And then I will say if while I plus 1 is less than equation.length, and equation I plus 1 I'll test whether they are numbers. So I'm gonna say the test then number will plus equals to equation I plus 1 and I plus plus, right? So this can actually condense into one expression, will be plus plus 1, plus plus I, which means that we increment I first, and then we use the I value, right? So yeah, now we have the number, then we are going to push this in to the stack. So we're gonna call push to stack and the number. I'm gonna convert it to a number, and we're gonna break, right? Okay, so we're gonna have a function called push to stack, which gives us a stack and a number to push. So if the top of the stack dot length, which is the stack is not empty, and stack dot stack dot length minus 1 is plus or a multiply, then we're gonna pop two things from the stack. So the first one will be the operator, and second one will be the number. So now the number to push would be equals to, depending on operator, if it's a plus, then we are going to number plus number to push, else is number times number to push, and we're gonna push it, right? Stack dot push number to push. Right, so we handle numbers, operators, space, and the last one would be a closing bracket. Right, so case closing brackets. In this case, we're gonna pop a number, and then opening brackets. As you can see here, we're gonna pop number. So we don't push this closing brackets. We're gonna pop number closing brackets, and then we'll push the number in. Right. So number equals to stack.pop, and then const, and then we pop out the opening brackets, which we'll throw in, discard away, and then we push back in. So push to stack and the number. Right. And I guess that is it. And before we end, we need to remember to increment I as well. Right. And then let's see how it goes. So probably before we run this, I'm gonna try out one of the equation over here. And let's see what we get. 51, which is correct. And now we have the confidence. Let's run through the actual inputs. Wow, that's a big number. And let's see. Okay, let's paste it in, and yes, that's the right answer. And let's head to part 2. So part 2, you managed to answer the child's questions and they finished part 1 of their homework, but they stuck when they reached the next section, and advanced math. So now addition and multiplication have different precedence level, okay, but they are not the ones that you are familiar with. Instead, addition is evaluated before multiplication. So in this example, to evaluate this is you add first. So we add 1 plus 2, add 3 plus 4, add 5 plus 6, and then we do the multiplication later. Right, so now we need to change our calculate function, and we're gonna see, and then we should get a different results now. Right, so now when we push items into the stack, we would only pop it when it is a plus. Right, so we only, right before we push this number, okay, so let's see. So when we want to push 3, we'll push it because it's not a plus, right? And then only when we are encountering a closing brackets, that's when we know that all this will not have any addition. Then we will collapse this and then evaluate it as 6. And then when we're pushing 6, we see that it's addition, then we add it up to become 7, right? And then we move on over here. We see 4 times 5 plus 6. I think all this is pretty similar, right? Because there's no precedence anywhere over here anymore. So let's try to change this, right? So one thing we change is that we only pop. When we push to stack, we only pop out the plus, right? So over here, we are very sure that it will always be number plus number to push. Okay. And over here, when we are popping out numbers from this one, we may want to pop out more than just one number, right? It may have multiple. They might have multiplication and some other numbers before we pop it out. So here we are going to check the top of the stack. So I'm going to call it number instead. Use a let instead because probably we're going to change the number. And then we're going to say while stack.leg minus 1 is equals to multiply. Because we only have plus and multiply, but when we multiply, plus will not will always be, when we want to push a number, it will always be evaluated, right? So we only left with multiply in this case. So if it's a multiplication, we are going to pop it out, and I'm gonna pop another number. And we are going to multiply it another number. And we're going to continue until we don't see a multiply sign anymore. Then we pop out the opening brackets and push back the numbers instead. Right? And that is it. And let's get Get back again, and let's try to evaluate this and see whether we get the right answer. Sorry. Paste it in, save, and gonna run. Whoops. Okay, it's incorrect. So basically, we might left out with another step where we may still have multiple numbers left when we reach the end of the string, because now we don't evaluate multiplication immediately, right? So when we reach the end, we will see that if the length is still greater than 1, in this case we have 5 items, then we will continuously pop out item and do the multiplication. Right, so at the end of here, I will say while stack.length is greater than 1, then I'm gonna pop out let number equals to stack.pop. Let operator equals to stack. I think we don't need the operator. Right, and then let's another. I guess over here we don't have to use the stack 0 anymore. We can have like results 1, because we're gonna do multiplication, so we're gonna result will always be we'll start with 1 and then we can keep times that number. So results times equals number. Let's see, greater than 0. Stack. If stack, I think greater than 1 is okay. I think right here we can still results time equals to stack.pop, the last number, right? So here you can simplify a bit. We can say results times equals to stack.pop, and we pop out the multiply, and then the last one will be results stack.pop, and then we return results. Let's try run this again, and 231 is the answer, correct? So we are now going to copy the actual inputs in, and let's give this a run. Okay, let's copy this number and let's see whether we are correct. And yes, that's the right answer. So this is day 18th, and we have solved day 18. So if you like this video, give me a thumbs up. If you feel that there is something that can improve on, please comment down below. And that's all. See you on the next video. So please be sure to subscribe my channel if you want to get notified when the next one is out. So see ya. Bye bye.